Thank you so much. Good afternoon, everyone. Hopefully, after lunch, folks are not in food coma. So today I'm going to talk about data-driven software security. So even though we work for Microsoft Security Response Center, so generally in the security community, people commonly think, the response center as, like, oh, you work on reactive security. But actually, we do much more. In addition to reactive security, we work a lot towards software security defense, as well as we look into kind of trends, exploitation, information over the years, not just like, a month, 2 or 3. So today I'm going to talk about how we have analyzed those data and, have developed mitigation technologies and techniques to basically, block the attack vectors or basically, literally eliminate, class of vulnerabilities altogether. And with that, so in MSRC, generally we see, anytime a security vulnerability is reported, so or more or less, we follow our, security find, fix, and the finish. I'm sure everyone in this room knows Patch Tuesday. Let me know who doesn't know Patch Tuesday in the room. So basically, this is what kind of goes towards the Patch Tuesday releases. So anytime any security vulnerability is reported to us, and there are multiple channels, security vulnerabilities are reported to us. It could be through our awesome security researchers across the globe, or our own internal fuzzing, or through media, through Twitter, or through GitHub, or other places, as well as our security engineers also do code review. When they do code review and see security issues, so we do look into those. And once we find those vulnerabilities, it's not that just we do a point fix. So then it comes to the point towards fix. So a lot of time, when a security vulnerability is reported to us, for example, in one platform, so we generally go back and kind of look through the broad spectrum of affected products. So a lot of time, like if there's a vulnerability reported against Windows 7, so it's not that we go and kind of just fix the vulnerability in Windows 7. We go and look across all the supported platform. So today, all of our platform have their like support lifecycle. So once a product is released, there is a mainstream support, and then there's extended stream support for providing the security vulnerability, security solutions, or the security updates. So today, for example, we support the Vista SP2 through latest Windows 10 anniversary update. So any bug reported in Windows or in any other product, we look into all the affected software, services, devices, name anything. And once our engineers complete the root cause analysis, we do kind of use that root cause analysis to basically like analyze what's the kind of trend in the market. How many vulnerabilities we have seen across memory corruption? How many vulnerabilities we have seen around buffer overflow, or heap spraying, or just like font type confusion, or other vulnerabilities. So we use all that data to basically like understand like what areas of the product are basically kind of we should think about hardening or reduce the attack surface area. So when we fix those security vulnerabilities, we basically end up doing the thorough security review of the product. We do variant investigation, find similar issues in other products, as well as like similar issue in other areas of the code, and which we call as variant investigation. So it's a long process. If you see scope of the work that gets done for a single vulnerability, it's quite a handful of work. And even though fix is ready, it's not just we can go and just ship the fix, because knowing the Windows ecosystem or the whole Microsoft ecosystem, we need to kind of do rigorous testing. So every fix goes through a rigorous test pass, like functional testing, regression testing, and all multiple test passes before it is ready for Patch Tuesday. So that's where the finish comes in. So as we get closer to the Patch Tuesday release, we document, we assign a CVE, we provide the details, what are the attack vectors, what is exploitation index, like how customers can protect themselves, and if there are additional instructions they need to follow to basically protect themselves. So we release KBs, like I'm sure if you guys have seen kind of Bulletin. How many of you guys have seen Bulletin? Let's make it a little interactive. Anyone? Bulletin, security bulletins? Do you guys deal with it? There you go. So, so security bulletin talks about any particular, like security vulnerability, details, as well as affected platforms. So there you can see huge list of tables. So think about it. It's not just a table. You have to go and basically, do the root cause analysis of each of those, then create a fix, test a fix, and then when it is ready, push through the Windows update to the customers. So it requires a lot of coordination with multiple teams within Microsoft. A lot of time it could be that they are geographically distributed also. So it requires a good amount of kind of coordination, across the team, as well as we basically mobilize. If there's a security incident, then we mobilize, resources across the globe, not just kind of, because it's just the nature of security, right? So with that, so inbox product security, basically, security patches take longer because of the test pass and all the additional work required. However, online services fixes are pretty, like it doesn't take that long. You get a fix ready, do a quick, test on a pre-production environment, and just roll out the fix. So that was great. So online services, security fixes, they generally don't wait for Patch Tuesday. They get rolled out as they get ready. And they don't get CVEs or they don't get, like security bulletins, because most of the time customer doesn't really need to take an action because online services is already updated by, Microsoft folks. So with that, basically, as an MSRC organization, we distribute mainly, the timely authoritative security guidance, as well as, updates to customers, industry partners, and also security community. So Patch Tuesday is great for customers. However, it's also a boon for the hackers because they know that there's a security patch, released for. So a lot of times they take that patch, do the diff from the previous version of the product, or and reverse engineer the fix, and sometimes use that information to basically create a weaponized POC to carry out a successful attack for the customers who haven't deployed the patches, which is why we always tell our customers, apply patches, ASAP, because once information is public, it's just a matter of few days before hackers can use that information and create weaponized POC. So along those lines, this is our kind of like day-to-day stuff. But while we do this, so we also kind of take a pause and look kind of what went into the pipeline from last 10 years. And how, like all these mitigation projects we have been working upon. So the whole idea behind this data-driven security was mainly how we can use the knowledge, because we have seen all. So it's such a rich set of data which we can use to leverage, and leverage to reduce attack surface area, as well as disrupt, basically, like attack chain. So that was one of the motivation for our mitigation projects, and we've been working for a long time. It's just not like just a year or two we started working on mitigation projects, and partly because these projects require a lot of design changes, and they need to get introduced earlier in the product life cycle. So apart from just the responsive security, this is proactive as well as like attack surface reduction research work or science project that our team does. So I'm responsible for Windows mitigation projects in my team, and I'll talk about those in our next couple of slides. So having looked into the data over the years, so we analyze the vulnerability reports and trends. Where it is going. Is it going up or is it going down? And how we can basically, like using that. For example, we looked up trends for the memory corruption. We looked up trends for the, like confusion type or, heap spraying. vulnerabilities, and also for font parsing vulnerabilities. And having used that data, what are the areas? Or it's basically like cherry picking. Like, hey, looks like there's an opportunity to basically like block this whole like attack surface area and make it expensive for hackers to basically like exploit these vulnerabilities. So those were the motivation, and mainly the whole kind of goal of this mitigation project was mainly like, is there a way we can eliminate certain class of vulnerabilities like memory corruption, or break the exploitation techniques, for example, kernel ASLR, so add those mitigation techniques so that you can make it harder for the attackers to basically, carry out a successful attack. So it takes a lot of thinking and a lot of data crunching, as well as, like a lot of technology discussions. And not just our team, we have to work with product teams, as well as, our offensive security research team, as well as, like a lot of kind of, coordination with other teams at Microsoft before even we kind of, start discussing these. So at the same time, we want to best thing for our customers, same thing, best thing kind of, like how we can improve security of Microsoft products. That's one of the kind of, motivation. So this graph, pretty loaded graph. So this graph kind of, gives you a overview of, what we have achieved over the years by investing in mitigation. So the first graph talks about, just click, okay. So here, this first graph talks about like, from in last 10 years, you see the number of vulnerabilities keeps on increasing. It's almost like kind of, if not fourfold, at least threefold. Partly because, like, okay, hacker community is pretty active, as well as newer products are in the market as well. So you can see number of remote code execution and elevation of privilege, CVs by patch year. So you can see like, like last year we shipped like 414 CVs just for kind of, pretty, like huge number. So this number also tells how much hard we work. So even though like, the number of CVs have increased over the years, look at this chart. So this chart talks about, let me explain a little bit detail about this chart. So in this chart, if you really pay attention, it's mainly the green ones are the, like vulnerabilities for which we never saw any post-exploitation after the release. But if you see the purple ones, so those are the vulnerabilities which after, the security patch release, we have seen like, exploitation still happens. So the reason there was a drastic, kind of, like you see this deceleration or the, like a drastic reduction in number of the cases which get actively exploited after the post-release because of the mitigations, we have built in our platforms as well as in our browser space. And that's the kind of, like the goal. So basically all the work which we have been doing in the last 5 years, so you can clearly see there's like a lot of value, we are seeing it, and which kind of, makes it really kind of, win-win. But at the same time, as we come up with newer mitigation, hackers find other ways to kind of, like bypass those, like mitigations also. So we actively work with the security community, and we have, bounty programs as well as, our partner programs with which basically we try to kind of, like work with them and see if there are more innovative ways we can develop, solutions. So this is kind of, like really, so looking at the data, you can see like we have like, 10 years of data, like really pumping in and kind of, how much, like security landscape has changed and how, and again, so last year, for example, we have like multiple Windows releases, like from Windows XP through Windows 10. And this chart doesn't include this year's data because it wouldn't have been an apple-to-apple comparison because we are doing, year-to-year comparison. So with that, basically, with this, basically, I'll kind of, do a little dive in our mitigation projects, but the whole result kind of, shows the value, the mitigations which we have built in is definitely kind of, causing pain to the hackers to kind of, exploit the vulnerabilities. So with that, let's go a little bit deeper on mitigations. So we built in a lot of mitigations in Windows 10 platforms. So Windows 10 was shipped, last year in July, and so a couple of mitigation that got built in, and the goal of each of these mitigation was to basically address certain class of vulnerabilities. So as I'll go through each of those, I'll talk about what vulnerabilities were kind of were the target or were blocked by these particular mitigation. So the control flow guard, it was enabled by default for the user mode, which basically helped like memory corruption, or basically literally shut down all classes of IE RCE vulnerabilities. And the another, I'll talk in detail also. So this was more of a kind of snapshot of the mitigation, and coming slides will have more details. So the other mitigation that we built in to the platform was the hypervisor enforced code integrity, with which basically we ensured that there's a strong code integrity for kernel mode. So this particular mitigation was mainly targeted towards the kernel mode exploitation. So having this mitigation in place literally have reduced a lot of EOPs, vulnerabilities for us. And with that, even though user is able to have a remote code execution, or but it can only happen in a user mode. It will not happen, or they won't get elevation of privilege. And the third one was very near and dear to my heart, is UMFD. So I own Windows graphics area from last 2 years in our MSRC team, and it has been busy. So in Windows 10, we shipped user mode font driver. So with this, basically, one of the kind of win from there was basically, we were blocking of untrusted fonts to help eliminate the attack vectors for, via font parsing. So fonts were used to, most of the time, like prior to Windows 10, fonts were executed in kernel mode. That basically, with that, basically you get remote code execution, like even from the IE, vector. So this was one of the kind of area which we saw, like there was a spike in, like reports, as well as spike in the CVE which we shipped. So this really kind of, like helped us to kind of, reduce, the attack surface area from Windows 10 plus platforms. Having said that, we still service down-level platforms because we have to service, all the in-support products. But good thing as we march forward, so we know, like user mode font, like this mitigation basically takes care of a lot of font vulnerabilities. And for Edge, there was a lot of work that got done during the Windows timeframe for Edge. So there was a huge amount of attack surface reduction that we did in Windows 10. So App Container. So App Container, it provides a strong sandboxing, and isolation for application for Windows. So that, and this was on by default. So which basically meant if there is a code execution happens in IE world, basically it will be still in App Container, context. So at the max, an attacker can gain, it would be like the user, like privileges, they cannot break, unless they break out of the App Container or the sandbox, they will not be getting remote code execution at system level. And the second one is the 16-bit by default. So 16-bit by default, this was mainly to kind of, improve or to kind of, like take advantage of the increased entropy for ASLR. So in 64-bit address space, having 64-bit address space, so we could make, or we were able to kind of take advantage of higher entropy ASLR, which was 24-bit. So having said that, which exactly it means, so if you look in address space, so having that 24-bit entropy was basically 1 terabyte of variance before the heap can start. So which basically having this one literally shot down heat spray attacks. So with this, Edge is much like secure. Edge is secure platform as compared to IE, and with that we have seen like 56% of the vulnerabilities which we shipped in last year are not applicable to Edge. So 56% of vulnerabilities which are applicable to IE are not applicable to Edge. And in Edge, as part of the attack surface reduction, we basically remove a lot of like old code. For example, there was no legacy document modes. There was no legacy script engine support, like VB engine or JavaScript engine, or as well as there was no vector markup language, there was no toolbars, no browser helper objects, and no ActiveX controls. So removing all that, and which basically meant was that there was a lot of code removal that had happened, and which basically reduced the attack surface and also provided the value. So we can see the number of CVEs which are applicable to Edge, and so Edge is much secure browser as compared to the IE11. And the third mitigation that got built on the Windows 10, like last year, and on that time frame was memgc. It was basically, it's a garbage collector. So what did this garbage collector? It was a conservative garbage collector, for the DOM engine. So what it did, basically, it literally took care of all the use after free vulnerabilities and make them non-exploitable. Because previously, those were the vulnerabilities were used by hackers to basically, like carry out code. They were using use after free to kind of, get elevation privilege or, remote code execution. So this really shot down. So having just these three, mitigation in Edge literally shot down memory corruption, class of vulnerabilities, 64-bit shot down heap spraying, vulnerabilities, and the memgc literally shot down the use after free, non-exploitable. And if anyone can kind of really, if hackers can still, they cannot, and as a result of this, we saw in last 2 years, there is no zero-day attack on IE, there's on Edge, and we haven't seen any, like RCE or zero-day, in Edge platform or Edge on Windows 8 plus or Windows 10 platforms. So this was, overall, the whole work kind of, gave the value, and that, which is why kind of, if we look back, it's kind of, gives us like, okay, so much of kind of, engineering work which we did, and it was not like just we wanted to do it. We looked the data because we used the root cause analysis for the previous year's vulnerabilities, and we picked up these areas where we wanted to do the hardening. So these were the Windows 10 mitigations, and this year, just last month, we had Windows 10 anniversary updates. There are further improvements, like those got shipped for, for Windows 10 anniversary update. So a little bit more details kind of, along all the mitigation which I talked about in the last slide. So control flow guard, basically it's a built-in protection for the memory corruption. So, but what is control flow guard actually? So control flow guard, when it was introduced, it's lightweight security check, during the compile time frame. What basically it does is basically it checks, whether the target is, legit. If it is not valid target, it generally, because that's what hackers have been using it, to basically insert, ROP or, their shell code to execute. So with this one, basically, it will verify that the call target is valid at the runtime. If it is not valid, it will just crash. So no success kind of, for hackers to, execute a successful attack. And one thing which really kind of helped, so enabling, so we enabled, CFG, not just for IE and the Edge. We also enabled for, like all different processes for Windows. So, which basically, the goal is that will make Windows secure platform to build, apps. And we continue to explore the ways to, improve CFG to more strongly, and to more strongly prevent control flow hijacking. So this work is basically, after we shipped CFG last year, there are continual improvements we have been making, and some of them came through the mitigation bypass bounty programs. Some of them, like were reported by security researchers. So we still take, like all the, if you guys have suggestions or if you guys have any bypass, like reports or anything, submit to us. We'll definitely evaluate for, bounty, mitigation bypass bounty, and I'll talk about it later in the session about those. So the second one, second mitigation that got introduced was the code integrity enforcement. So code integrity enforcement was mainly to, like secure boot was introduced in Windows 10 last year. So it basically ensures that, everything that boots up on a platform, it has to come from a trusted authority, which means basically, having this enforcement, we were able to control, like any DLL, like loading or malicious DLL loading, as well as, like malicious images. So this really had helped kind of, to ensure that, only the code which is really, signed by a trusted authority gets loaded on a platform. So that also kind of took care of a huge number of vulnerabilities. And we also added, kernel mode code integrity. So there were a couple of features that got added in Windows 10 that was mainly for, that ensured that, any code which you run in kernel is also signed by the trusted authority. So, and that some of it is also tied with, like for example, we don't load any more, untrusted fonts. We only load, fonts which are signed, so some of these enforcement really resulted in literally killing, like kernel, exploitation techniques. So this has kind of, really bringing, this has reduced, like EOP vulnerabilities. So, and we are kind of, as we kind of, so in Windows 10 improvement, an anniversary update, we actually did some more enhancements to, what we did last year. So it's like a kind of incremental approach we follow for our mitigations. So I'll talk about more, what we added like this year. So as part of the code integrity, enforcement, so virtualization-based security, that got introduced, last year. So I didn't realize the color. I hope people can still see. It's not kind of literally blurred. So, so this is the virtual secure mode architecture. So as you can see, normally, like you run your Windows, the process, and then they have like, kernel mode and user mode. So, but in secure mode, this whole kind of was a new concept that got added. So this basically helped to enforce, the integrity check. So, and then HyperGuard was introduced, later after the, so Windows 10 first was shipped, I think July 26th last year, and then, the Windows 10 15.11 was shipped back in November. So HyperGuard was kind of a component, that got shipped around that time, and it is always active. So the whole virtualization-based security takes the advantage of the hypervisor along with the secure mode. So what it does basically, HyperGuard, it takes the advantage of the HVCI capabilities to block the modification. So basically, the way in the past, attackers were able to kind of, modify the state registers or the descriptor register or the control registers in the kernel. So having this, new technology and the new, like way to enforce, hypervisor enforce code integrity, even if they get a control of kernel, they cannot. They will not get the kind of code integrity confirmation from the secure mode. So this really, really helped overall the, the Hyper-V and the guest OS. So people who would like to run, like Hyper-V machines, as well as, in a cloud environment, when you use deploy different, machines as a guest OS, and you have a host OS, and then you install multiple guest OS rather than using multiple resources, separate machines. You can have like 10 machines running on the single, like powerful machine. So this was overall, this really helped to ensure that kernel mode integrity, was attested by the hypervisor enforced code integrity. And a little bit more details. You can read it, but I just added some more details because there's like a whole lot, went into the virtualization-based security. So before Windows 10, what used to happen, code integrity enforcement used to happen only in kernel. So when kernel used to do that, so what happens if kernel is compromised? So basically, there you go. It didn't kind of, help much, because if kernel is compromised and everything is getting kind of a code integrity check used to happen in kernel, then basically game over there, right? So having this hypervisor enforced code integrity really kind of brought the validation or the integrity check or management of integrity check outside of the kernel, so that even if the kernel gets compromised, you cannot modify, you cannot modify registers or memory state registers. So this basically eliminated most memory-based attacks, which was a big win overall, and definitely makes it harder for attackers to come up with the whole chain of attack. Okay, so the third mitigation that got added in Windows 10 was a user mode font driver. The reason I say it's really near dear to my heart because graphics space is crazy. And being a kind of owner of graphics issues in my team, it's kind of, like I really know in and out of kind of each and every kind of, security issue we deal with, every CVE we ship. So, and font space has been there for a long time. And one of the kind of, favorite in every hacker, like conferences, you see like, oh, GDI vulnerabilities. And this slide talks about a little bit history of GDI. So basically, GDI is comprised of 4 types of fonts. One is the TTF, true type font. Another one is open type font, OTF. Because a lot of time people use so much acronyms, they don't know, oh, okay, what is TTF? And bitmap and the vector, So in Windows 10, we decided that, okay, we don't want font parsing in the, executing in the kernel mode. So we moved into the user mode. That basically, really helped in a way for overall that even if, anyone kind of exploit any of those, font parsing bugs. So since now today it happens in a user mode, context, at the max, they can get a code execution, but only the user privileges, but not EOPs. So with this overall, we were able to literally shut down, like the class of vulnerabilities, EOP, kernel EOP vulnerabilities for font parsing bugs. So this is another win, and has definitely helped us kind of, seeing the, post-exploitation of vulnerabilities. So these were the, like mitigations which we shipped, during last year with Windows 10. And from here onwards, I'll talk about more this year. Just last month, less than I think a month ago, we shipped the anniversary update. So we didn't stop at Windows 10, even though it took like like a design level changes, and it took a lot of work to kind of and multiple coordination with multiple teams across the company to basically implement all these mitigations in place. Some of these required design level changes. So design level changes doesn't happen that you just code it and kind of ship the features, because it affects particularly Windows is such a huge code base. So if we have to talk about DCR, we need to talk about ecosystem. We have to make sure app compat, like we need to look into app compat. We need to also look into like, is there any regression? Are there any functional regression that is going to cause by those design changes? So it's not very simple that we can just turn around in a kind of 6 months or so. We have to do we have to put a lot of thought process before a lot of prototyping before this really gets kind of materializes and we can kind of ship in as a commercial product. So in Windows 10 anniversary update, having learned from last year, July 2015 till this year, so we saw kind of like we did a little bit deeper dive into like the issues which were still kind of viable, or the vulnerabilities which can still be exploited. So those drove some of these mitigation projects or mitigation in platform, as well as improvements for the control flow guard. So I'll talk about each of these a little bit more details in the next slides. So now we saw kind of range of like reports, or we were seeing kind of looking into the overall like attack chains, as well as how like how attackers are kind of using the information. So kernel SLR turned out to be kind of winner into that okay, they are able to, so hackers are able to get the kernel pointer addresses through user mode, or from addresses, because there was a predictable prior to Windows 10 anniversary update, there was a kernel SLR, but the randomization or the entropy was not good enough. So with this, basically the whole 64-bit kernel space layout is fully dynamic, which makes it like kind of, it's very, very hard to predict now the kernel addresses, which was easier prior to this mitigation. So this basically what it does, it's basically, PXE randomization is applied to various inter-kernel regions, which basically, makes it harder. So even though, like it's not easy to get the kernel pointer addresses anymore, but it makes it really, really harder for hackers to, get those addresses and then, carry out successful attack. And another, as part of the SLR improvements, page table self-reference map and PFM, it's page frame numbers database was also randomized. So even previously, hackers were able to kind of predict, like, okay, okay, XFFFF, oh, you can get kind of, memory addresses. So with this, now the page table self-reference is also randomized. So it makes it really, really hard to kind of, now attackers have to come up with maybe some novel technologies or some novel techniques to basically, get the kernel pointer addresses to carry out elevation of privilege attack or, use after free any of those vulnerabilities. And as part of this work, we also did like GDI is basically, it's a graphics device interface. So it used to have a shared handle table where, like kernel memory addresses were shared. So that was another kind of area which was used, a whole lot by the attackers. So in Windows 10 anniversary upgrade, we basically, that particular shared table no longer, leak any kernel addresses, no kernel point addresses. That basically, take away one of the kind of brownie points for, the hackers to carry out an attack. And it also basically, the whole goal of this kernel SLR mitigation that got built, in a newer platform is mainly to kind of, let's just break the exploitation technique, make it harder for the hackers, make it difficult, like even if they get kind of, by the time they end up developing a weaponized POC, customers have enough time to kind of, patch those vulnerabilities. So these mitigations are really, paying off, as well as, we are open for suggestions, we are open for, feedbacks, as well as, like more bugs, more bounty. Absolutely. So with that, so this is the second mitigation we added in our anniversary update, basically child process restriction. Previously, last year, when we shipped, like app container or the sandbox, it was still possible that, like sandbox process can create a child process, and then they can get the EOP or get the, impersonation. So with this child process restriction, it really helped in a way that now you cannot, execute code by launching a child process, as well as you basically, you cannot bypass CFG just because you can create a child, process. And also, there are checks that got introduced that you cannot just impersonate, like tokens or you cannot just inherit impersonation, and ensures that there is, you don't really kind of get more privilege than, like a process has. And it also, so the last bullet talks about how, you can add these child process restriction to any of your processes. So there is a whole lot of documentation which got published in MSDN, and I have those pointers at the end of the slide in resources. So feel free to kind of take a look. If you're app developer or, it's really great if you can take good use. You should, use these, implementations, because this really helps. Like, you can protect your apps because most of the apps will run in the app container environment. So those are good. And as part of additional mitigations, we also did improvements in our CFG. So control flow guard, even though, so last year it used to be check mode, but this year, we received one of the bounty submission for this one, mitigation bypass, and they did qualify. So as part of kind of, investigation works we did, we basically introduced the dispatch mode. So in dispatch, the difference between the check mode and the dispatch mode is mainly the dispatch mode check basically verifies the target is valid and then jumps to it. Because previously it was, it used to check later, but by the time the code jump has already been made. And most of the, improvements which are kind of, listed here, they were all, I think some of them, not all of them, some of them came through the mitigation bypass bounty. and they were successful bounties. So we implemented, those changes, and we integrated, those improvements in the latest, anniversary update for the CFG guard improvements. So the whole goal of the CFG is mainly to ensure that, when you do a memory jump or when you for the target memory, you basically validate whether it's a valid target or not before you even kind of, allow the code to execute. And in addition to that, we also did some more additional work on edge isolation and containment improvements. So containments was mainly around the app container. So Flash, I think everyone knows Flash. It has been an interesting year overall for the Flash because I think almost every month there were kind of, like CVEs getting shipped. And since it used to be run previously in, like in process, so we also have to ship patch because Adobe, so the Flash was shipped, along with IE in Microsoft products. So in anniversary update, we basically, improved the isolation, and it has its own app container now, which is kind of, which should help overall that if anyone can kind of, get the remote code execution or any of the code execution, it will only happen in that app context. They will not be able to kind of affect, the system. And Win32k system call filtering was enabled for the edge processes. This is really, really good because with this one, we are reducing, the kernel attack surface area. So even if an attacker is able to basically, like, so edge content process, even if they kind of, end up getting a code execution, it will only run under that app container context. So which kind of, is overall a win-win. And so with Win32k system call filtering enabled for edge, it is kind of, really helpful because with that, edge is basically the, like internet, like facing product. So most of the time, kind of, like attackers kind of social engineer, like users through IE or, like clicking on links or those. So IE and Edge has been always kind of, one of the primary focus for mitigations for us. And after implementing these mitigation, it really, really helped that, we can reduce the overall attack surface area for Edge, as well as with this mitigation, reduce the attack surface area for kernel also. With that, the last mitigation, we introduced in anniversary update is basically now you have guest VSM support also. So in secure kernel, even though we shipped last year, but it was not supporting the guest VMs running on a, like Windows 10. So now, so if you are running Windows anniversary update on a guest VM on a host OS, you can basically you can utilize the secure kernel capabilities, and you can use those functionalities to basically, run your guest VMs. And with this, basically, each guest brings its own secure kernel instance. So it's purely kind of isolated environment. So your guest VM will never interact with the host OS, partly thanks to the, capabilities, from the secure kernel mode. So it really helped overall. So these were the kind of, mitigations we developed in our anniversary update. And thanks to all this hard work, which, whole team has put on, and not just our team, but other, like engineering teams, as well as other, Microsoft teams who were part of this work, which has reduced, the attack surface area across the Microsoft products through platform, as well as in IE and Edge products. And we already see that kind of, like reduction in number of zero-day attacks, as well as, like number of CVEs which we ship. So with that, I would like to talk about the Microsoft Bounty programs. So we have seen that, security researchers, across the globe, like really awesome work which they do. So we have seen really great work submitted to us through our bounty programs. So which basically kind of, encouraged overall to encourage more, like more to our security communities that, hey, submit, like if you guys have any of those bugs. So some of these bounty program are, I think, still open. All of these are still open as of today, But I believe .NET Core and ASP.NET Core RC2 bug bounty will close in probably next 1 week or 2. So if you have any bugs or you are aware of any vulnerabilities in any of these areas, please kind of report to us. That would be great. And please note that mitigation bypass bounty, we pay up to 100K. And in addition to that, if you also provide a defense, like technology or defense, defense solution for those, then you get another 100K. So here's your kind of, we encourage security researchers to kind of, if you are interested and if you are working in these areas, you have suggestion, do report to us. And any, like bounty-related submissions, you should always submit to us at secure@microsoft.com. Feel free to add bounty@microsoft.com also, but there are specific regulation or the rules and the policies that are posted. So this particular slide, each of these is a hyperlink. So if you need more information, you can go and take a look into those. With that, I'll wrap up my presentation. These are additional resources. You can get more detailed information for all the topics which I covered during this talk. So overall, to wrap it up, so the goal of all these mitigation that went into the all engineering work which we did, basically to eliminate class of vulnerabilities, as well as basically make it harder, like break the exploitation techniques. And we have seen good results coming out of it, and at the same time, we continue to improve our products, and as we move forward, we'll continue to take the feedback from customers, as well as from our security researchers, as well as from the bounty programs. We'll make our products better. With that, if you have a question, you get a bonus point. I have 3 bounty t-shirts, so first 3 questions get the bounty t-shirts. Woohoo!
Thank you, Sweety.
Right. So,
any question?
Any questions from the floor? And you're gonna get a goodies from Miss Sweety, Microsoft.
Woohoo! That's a bounty t-shirt. You get a ninja logo also of Windows. There you go. That motivated someone. Yes, please.
Hi, good afternoon. It's Anthony. You discussed a while ago about the graphs on showing the difference between where patching in before and after. I was just interested on how were you able to gather those informations comparing the before and after the patching. Particularly, how did you measure and came about displaying the graph showing that the items that were not able to exploit already?
Okay. So let me repeat your question just to ensure I understand your question. So you mentioned that, like the second graph which we talked about was post-release, exploitation, and how do we distinguish between kind of, before the patch, if there's any exploitation. So please note that if any of the vulnerabilities or any of the issues are under active exploit, we do call it out in our bulletins, like, it's a limited targeted attack, or there is, and you can also look at the exploitation index, or, which basically talks about like, oh, okay. And we have a huge partnership in the whole, ecosystem. So we work with, and it's not just our kind of, analysis or just we detected. All our, map partners, so we have, Microsoft Active Protection Program. So we share, like detection mechanisms with other partners, and if they find anything, they report to us too. So we are very transparent about if we are aware of any vulnerability which is like under active attack or, like prior to patching it, we do disclose that. So in this particular graph, we didn't take that into account. We just take into account like post, exploitation, because partly we did provide it a fix, and then people ended up kind of, or hackers kind of, reverse engineer it. So M or L? M, okay, sure. Let's see, how are my throwing kind of skills? It has been a long time I've played cricket. Anyone else?
Any questions? Or Sweety gonna bring back the t-shirt, so
Ooh.
please ask the question.
Maybe this one.
No more?
No more?
Question, guys?
Wow, everyone just got everything. That's cool. My job is done then.
Oh, there is a question.
Oh, okay, sure.
how can we find out more about the bug bounty programs that Microsoft has?
Oh, absolutely. So there is, so if you go in, just go Bing or Google, just type Microsoft Bounty Program. So the first URL that you get, it lists out all the open bounty program we have today. And it also lists out the policy and the kind of, like what is expected of each of those submissions. And later when you get the slides, whenever it gets posted, so all of those links are available also on the slide. I hope links work in PDF too, right?
Yeah, correct.
Yeah, there you go. L or M. Okay, I know.
And we have the last question
that's the difference, kind of, you come from the United States, everyone just takes L. And my bad, I should have brought some small sizes too. There you go.
Hi.
So the last question.
Yeah, we have the last question.
Okay. Yes.
Since you mentioned about the anniversary update,
Yes.
so it came with the canonical Linux kernel also?
Sorry, can you
The
repeat
canonical cooperation with Microsoft that brings a Linux subsystem in the Windows?
again? Yes.
Yeah, I'm wondering if you have any info whether it will increase the security level or decrease the security level of Windows in general.
So Windows subsystem for Linux, it is basically, like Ubuntu binaries. Basically, people basically app developers and all the people who are used to using, Linux environment. For them, basically, we wanted to open our platform for them to kind of develop apps. That was one of the reasons. So depending upon where the vulnerability exists, if the vulnerability exists in any of our Windows component, we will take the fix. However, but it's not a default Windows, installation, because you need to kind of enable app developer, certain kind of settings before even you can use the WSL features. And if it's a vulnerability in Ubuntu, then we work with Ubuntu folks to kind of patch that. And as they patch, basically you get the notification, in the Ubuntu, I think they have a web page where they kind of list out the latest version and whenever the patch gets updated. Cool. I'm sorry, I have only L sizes. But with that, I'll throw in one more thing. You get a nice, fancy bounty bag. Woohoo! There you go. With that, thank you very much, everyone, for your time. And yeah, my pleasure. And
yes,
feel free to send me email if you have any questions. So my personal email is Sweety, SWEETYC @Microsoft.com. More than happy to kind of, answer any questions you guys have. And again, if you guys have any, security questions, security-related, issue or anything, feel free to email secure@Microsoft.com. It is 24/7 monitored alias. And we have a 24 hours SLA, so you'll get a response. If not from me, I don't run secure but if needed, I can definitely go and poke people like, hey, did you receive something? Cool, okay, thank you, everyone. I appreciate that.
Thank you.